Thanks for tuning in today. I'm Dr. Nick, the Incrementalist. Join me as I seek out the small incremental changes being applied in other industries that we can learn from and that can be applied in healthcare. Can these changes bring immediate value, but also add up to the big improvements and revolution we need in healthcare? Come along with me to explore the possibilities. My innovative guests from around the globe have used small incremental improvements to achieve their moonshot. And today I'm delighted to be joined by Dr. Brian Powers. He's an internal medicine resident at the Brigham and Women's, and also one of the co-authors of a recently published research article dissecting racial bias in an algorithm used to manage the health of populations. Brian, thanks for joining me today.
Thanks so much for having me.
If we can, let's start off just to give the listeners a little bit of a sense of you. Tell us about your background and how you arrived at this point in this article, which certainly created a lot of waves, not least of all with the American Medical Association president, who I interviewed a couple of weeks ago, who was specifically talking about this. Tell us a little bit about your background, if you would, please.
Absolutely. Somewhat of a wide-ranging background, even obviously early in my career. In undergrad, I actually majored in history, was focused on the intersection of race and medicine, but in a different way. I was focused on the historical origin, looking specifically at African-American physicians who practiced medicine before the Civil War and the personal and professional challenges that they encountered. I took a turn away from pursuing history studies further after leaving college and did a stint at the Institute of Medicine in Washington, D.C., which is now the National Academy of Medicine, focused on domestic healthcare policy. So it's around the time when this was in 2010, so when the Affordable Care Act was being implemented. And there was a lot of attention and energy in D.C. around making our healthcare system more effective, more efficient, more sustainable. And that's the sort of perspective about, again, how to make the healthcare system more effective and more efficient that I took with me to medical school. And I was up here in Boston at Harvard for medical school, and also did the dual MD MBA program, so got my MBA along the way. And this is a project that actually began during medical school. And my co-authors and I were looking at, there was more and more attention around machine learning and predictive analytics. And we were specifically looking at the way it's being used for care management programs. So how predictive algorithms are being used to identify patients that might need extra resources, broadly construed, specifically in this case, care management resources. And we wanted to see, whether there would be applications for machine learning and access to electronic medical record data to better predict who would need these sorts of services. And we received a grant from the National Institute of Healthcare Management Foundation to pursue this question. And it was really in the early stages of the data analysis and data cleanup and really preliminary analyses that we noticed a discrepancy in the risk scores that were being used. This is risk scores from an external vendor that the system we were studying uses as a starting point for assigning patients to the care management program. And we noticed that there was a discrepancy and that Black patients were being scored less highly. So they were being scored as less risky than white patients, which, since we know on average, Black patients, right. Yeah, typically you think of, again, on average, and the population we were studying is sicker. So it sort of it just caught our eye. And again, this was first pass sort of data cleanup and descriptive analyses on the data we received. And so it was not a project that intended to go in this direction, but based on that initial finding, sort of started digging deeper. And as you probably know, there's a growing concern and I think really just concern that using algorithms and machine learning more and more can perpetuate and sort of further encode biases that exist already in our society or in the data that they're being trained on. And so it was sort of a confluence of that broader concern in this type of literature and the possibility that we had maybe stumbled upon a unique data set to answer the question.
So it's interesting. The first instance of this, so this wasn't your intent when you went to study this, it was more sort of looking at it, but it was, so how was it that the data was presented that stood out? Because there's a part of me that imagines that it just gets buried. So you must have had some representation of that data that allowed you to see that difference. What was that?
So it was essentially just looking at sort of first pass tables of what percentage of patients in specific risk bins were of different races. And when we looked at the highest risk bins, the percentage of African American or Black patients seemed just surprisingly low to us. We expected that it would be much higher. And again, with the sort of ongoing awareness that this was a potential risk, it prompted us to dig deeper and then do some of the analyses that you saw. I think interesting parallel, one of the other co-authors, Christine Bogley, who works at Partners Healthcare, had mentioned in an interview following the paper that when her team was using a similar type of algorithm, they noted they were doing some heat mapping of different zip codes for which patients were most risky. And Partners Healthcare, based here in Boston, the zip codes that lit up the most were among the most affluent in Boston, and that caused her and her team to also scratch their head that this didn't quite make sense.
Yeah. So, and there's another part of this that is maybe not apparent to the listeners, but you glossed over it, but as part of your original thesis, you focused on the discrepancies or the challenges specifically of Black physicians trying to practice medicine pre-Civil War. Do you think that sort of helped tweak or refine your view of the data that allowed you, or is that just an additional data point?
I know it's a great question. I don't think it's purely coincidence. I think that all of myself and my co-authors, came to this project with an awareness and concern about disparities in healthcare. And so I think without that awareness and concern, that's held by many people, by no means just us, but we came to the project with that lens and with that context. And so I think that sort of primed us to notice some of these discrepancies. And then when we noticed them, dig deeper, as opposed to maybe saying, that's kind of odd, but not really what we were going after. Let's forge ahead. And I think for me, I've long held interest in the roots of disparities in medicine and what to do about it. It's taken different turns. It was from a very historical perspective early in my undergraduate thesis, policy perspective at the Institute of Medicine, now deal with it on a more sort of clinical perspective most days in the hospital. And so I think that's the context I brought to it. Christine Bogley, another co-author, she's done a lot of research in health disparities, health services research around health disparities. And then my other two co-authors, Diad and Senthil, bring their own concern about the specific issues with bias and algorithms. And so I think it was the confluence of all of us having that, and some component of that in our conscience as we first sifted through this data that I think you're right, probably caused us to maybe go this direction when others might not have.
Right. So I try and think about these things in terms of the journey and the steps that allow people. And, one of the things that I'm always looking for is, how do we help guide others to try and see data in those ways? And obviously all of those contributions. And I think what I heard you say in there is that when things don't, so it's partly this gut feel almost. And, the gut feel in your instance, I think, comes from all of this extensive experience, obviously the research that you've done, your co-authors likewise. But for others that maybe don't have that, I have a sense that initial discrepancy, which, for most people would probably stand out in some fashion, it's not to discount it. So, the rigors of science in this instance suggest that we shouldn't just accept, oh, well, that doesn't look right, let's move on because that's not interesting. Do you think that's fair? Is that a sort of helpful viewpoint for others to sort of try and adapt to and take that as their incremental step?
I think absolutely. And, there's a lesson for me in this project is that, we come into these, we're asking questions and you spend a lot of time writing a grant, in this case, getting funding, getting the data in line, starting the analysis. And there can be a pull to not deviate too much because it's obviously a question you've thought a lot about and it's important to you, or else you wouldn't have gone through the time and energy to get things lined up to answer that question. Right. So there's a lot of forces sort of trying to well, let's forge ahead. This is what we set out to do. This is what we're interested in. So it's a good lesson to me of the importance of pausing, and when something doesn't seem right, diving down that rabbit hole. And I think many times it's not going to pan out at all, or it might be less impactful than the original question. In this case, it was, I think, certainly more impactful than the original question we set out to answer. And you certainly don't know that going in, and it's, again, less likely to be the case. But again, it was a good lesson to sort of follow the data. And I think it's a story that spans a lot of science. I think there's a lot of sort of serendipitous scientific discoveries ranging from economics to health policy to basic science. And you only hear about the ones that turned into something significant, but that's certainly a thread in the stories of, how did you find this? How did we discover X drug? How did we come up with therapy for Y disease? There's often this, well, I was looking at something else and then this happened.
Right. No, I think that's a great point. That's, a lot of the visuals, and I've, referenced these in other places, is, the pathway to success is not this straight line, and it's full of these little dips and sojourns. But, the importance, I think, and I hear it clearly, is, pause. I think a key asset there is, stop this constant forward march. And review and think about it, but obviously with some limits around that say, there's a point at which you say, no, we've got to move on, but, having that opportunity to do so. And I think it's one that we miss in medicine because we're constantly being focused on this production value. So fascinating. For those of you just joining, I'm currently talking to Dr. Brian Powers. He's an internal medicine resident at the Brigham and Women's, and also one of the co-authors of a recently published paper on racial bias in algorithms. We were just talking about the sort of process to what got you here. But obviously the resounding question in my mind is, well, wait a second. I mean, my sense of this is the data's already got bias in it. I mean, to me, that feels like one of the sort of truisms in this, is that if you feed biased data, and I'm not saying it's deliberate bias on the part of people's actions, it's just, it's part of the system that we live in. How do you address, I mean, is this not just going to be the ultimate outcome for anything that uses data that already has bias in?
Yeah, it's a great question and a great point. I think the risk is certainly that without vigilance or attention, if we train algorithms on biased data, they are likely, if not certainly, to arrive at biased predictions that encode the same biases. I think there's a global reason to be optimistic and maybe a more specific reason to be optimistic in this sense. And the global reason is if you know the biases that exist in your data, you can think about how to develop and construct the algorithm, not the sort of innards of the algorithm and the specific sort of machine learning methods, but the broader way in which the choice of what to predict and then how to use that prediction. You can make choices around there that can, at a minimum, not reinforce the bias. And you can imagine a scenario where you can actually make decisions there in ways that could even address the bias. And so, the algorithms are just, it's all up to how we use them. And so if they're helping us make decisions, and so if we rely on our prior biased decisions to feed the algorithms, then the decisions they're going to help us make are also going to be biased. But if we get a little more clever and a little more deliberate in how they're used, you could imagine them actually forcing us to make decisions over time that are less biased, and then truly moving the needle on some of the biases that we uncovered here. For example, the reason our findings here were so concerning is that they sort of reinforce existing biases. So because Black patients have less access to healthcare, they're less likely to be flagged for additional attention and therefore incur lower costs, and that would just further make them score lower on the algorithm, get less healthcare, have lower costs, score lower, get less healthcare, have lower costs. It's a very regressive cycle. But if instead you used an algorithm to disproportionately target Black patients for care management, you could imagine and sort of address the systemic barriers that lead to less access and lower costs. You could actually reverse the underlying disparities and then therefore the underlying bias in the data.
Right, and as I read through the paper, one of the things that you talked about was labeling in this, and this is labeling of data as one of the methods. Can you share a little bit of insight into how we can approach that? What was it about the labeling and the methodology that helped you sort of flip that whole bias, that was
Mhm.
apparent in that?
So the source of bias in this case was that instead of predicting healthcare need, which is a hard thing to predict, we don't have a measure for that. The algorithm developers and the health systems that use these sorts of algorithms use healthcare cost as a proxy for healthcare needs. And it's a
Ah,
reasonable, and so that's the label difference, whether you're using cost or need. And it's a reasonable proxy because we know that on average, cost is correlated with need. The
right.
challenge is you're using a more sort of, distant measure of need when you choose cost. And the space between need and cost, while it's correlated, is where bias creeps in. And in this case, because of unequal access, unequal treatment, and distrust in the system, Black patients of equal need actually cost the system less. And so then that is where it breaks down. So if you just looked at Black patients, cost might be a decent proxy for need. And if you just looked at white patients, cost might be a decent proxy for need. But when you
Right.
lump, both races together, it breaks down. And so that is the sort of diagnosis of the problem, so to speak. It also points towards the solution, which is relatively simple in this case. And we start to spell some of this out in the paper is, well, if the reason bias creeps in is because of a labeling choice to use cost instead of need,
Hmm.
can you just pick a different label? You're actually not changing the data itself. The data is
Right.
still biased.
Yeah.
Black patients still access care less and cost less. But
Right.
what if we used just a different proxy for health need? And so we show a couple different ways to do this. One is just looking at the number of conditions that someone has been diagnosed with over the course of a year. And so predicting that as opposed to predicting their cost. So that patients with more diagnoses, more complex, higher healthcare needs. And then we also just, instead of looking at costs overall, we just look at specific costs for acute conditions. So that would be costs for inpatient admissions or emergency department visits, thinking that those are more acute, less likely, though still certainly subject to the structural barriers that cause Black patients to access less care, and maybe the types of admissions that care management is focused on anyway, the types of costs that better management and better care management could avoid. And so we conduct some simulations where instead of having the label be costs, we change the label to labels, whether it's inpatient and emergency visits or the number of chronic conditions. And most of the bias comes away when you do that, when you change the label to predict something more proximate, a closer proxy for health, and one that's less likely to be sort of impacted by systemic biases in our data.
So if I was to sort of pick out a couple of things, I think, precision in terms of the data labeling and the analysis, seems like an overarching theme. As I think about this, and I certainly got the sense of this as you're talking about it, and I am too. I mean, I think augmented intelligence, which is my preferred term, is an integral part of our future, not just in medicine, but just in general. And you describe it in positive terms, albeit, we've got challenges with this data and the source data and, there's potentially built-in bias. How do you think we're going to sort of cope and continue to move this forward to help us, develop a better solution? Because right now it feels a little bit like the Wild West to me. People sort of launch these algorithms, say they're great. I mean, I have other examples of, bias in different forms, not in this racial form, but in a bias against asthmatic patients. Or for them, in fact, who apparently were performing better in terms of outcomes if you had asthma in a particular hospital. And that was because they had an existing protocol that was incorporated into patients that came in that had asthma. They went straight to the intensive care unit. So they appeared to be asthma as a predictive disease that improved outcomes, which of course, intuitively we know is not wrong.
Right.
How do we deal with that going forward? Because they're essential to our future, right? But what you've done is you've highlighted this, but I'm not sure I can see exactly the pathway. Do you think there's an oversight that's required, a validation? How do we cope with this?
Yeah, so I think I agree that the solution here is to not use algorithms, right? The solution is to continue to use algorithms, and the specific issue we're focusing on, which is how to allocate intensive clinical resources to the patients that need it most, is not a task best suited for physicians, policymakers, just individuals. It requires the integration of too much data. There should certainly be clinical expertise that flows into that, and we actually have good data that clinicians are pretty good at picking the patients that would benefit from these programs. But to use your term, that should be augmented by other sources of data. So yeah, by no means I think any of myself or any of my co-authors feel that the solution here is to not use algorithms. It's just to use them more wisely. And I think that there are some, so in this specific case, there's a couple easy tweaks, which would be to change the labels and to do a couple other more technical things. But I think the broader question that you're asking is how do we not find ourselves in the situation again, but still embrace the use of algorithms and predictive models. So I think one item is sort of bringing the algorithm developers and the end users of the algorithms closer together. And I think some response from the clinician community and the delivery system community to our paper is like, well, of course, you weren't predicting healthcare need. You used this label that was inappropriate, and they are probably further along their journey than some other health systems of thinking about how best to use predictive models. And so if you maybe had a seasoned clinician or someone more experienced in the development and implementation of these care management programs in the data that they're trained on in the room with the folks developing the algorithm, the simple choice of what label to use could have been changed at the outset. And then all the inner machinery of the predictive model, the computational time and energy to code and tune and refine and implement, that all stays the same. It's just these sort of fundamental choices at the outset. And then to the point you raised, which I had seen that example before too, and very striking, is to have that same sort of expert input. And this doesn't apply just to medicine. I'm just using the examples of clinicians validating the results. And these aren't sort of particularly nuanced or complicated or technical evaluations. This is, does it just pass? Like you said, it doesn't make sense that asthmatic patients would be less likely to be to die or to be hospitalized, and just have someone with subject matter knowledge take a first pass at the output of the algorithm and see, does this make sense?
Fascinating. I think, great points in terms of that sort of future development. Unfortunately, we're almost out of time, so maybe I could just ask you as a sort of closing thought, what are your thoughts for the future and how some of this might be applied to help us solve some of the sort of core fundamental issues of our healthcare system? What would your guidance be?
Yeah, I think to stay on at least this theme of predictive analytics and algorithms, I think this is a sort of maybe a canary in the coal mine that we need to pause for a moment and assess how these algorithms are being used, lest they don't help us improve our healthcare system. They might just reinforce some of the challenges we already have, but at the same time, not swing too far in the other direction and sort of throw them out. And so I hope that it is sort of, as I mentioned before, an opportunity to prompt a closer union between those that develop and build predictive algorithms, experts in machine learning, and the clinicians, patients, and others who are ultimately using and implementing these models. And I think historically, there's some of that knowledge on the algorithm side has been harder to come by and held by fewer folks, and it ends up being sort of black box solutions and there's less collaboration. I think fortunately that's less the case now, and whether it's an organization bringing some of these skills in-house makes it easier to collaborate, or hopefully just some organizations that maybe will be a little more apt to sort of break down their walls and collaborate more closely and sort of open up the black box, so to speak, and allow more co-creation and hopefully less biased and less more effective algorithms in the process.
Fantastic. I think those are tremendous closing thoughts. Brian, it just remains for me to thank you for joining me. Fantastic paper, fantastic insights, and delighted that you have been that canary in the coal mine. So thanks for joining me today.
Absolutely. Thanks so much for having me.
Thanks for joining me today. Do you have any better ideas, or have you found a small incremental change that's brought about a big improvement in your world? Let's continue the conversation on our hashtag, The Incrementalist, or share with me at DrNick1 on Twitter. You can find more information about the show on our program page at healthcarenowradio.com, and tune in next time to hear my discussions with leaders and innovators from around the globe who've revolutionized their space by using small incremental improvements to achieve their moonshot. I'm Dr. Nick, the Incrementalist, and I'm starting a revolution through evolution.